All right, so I'm either going to finish 3-6 or come close to it. I have a couple buffer days. So it means we're actually going to probably finish early again, at which point I'll let you ask questions. And if the questions stop, then we'll just quit. So be ready to ask lots of questions the next several days, I guess, leading up to the exam on Friday, okay? So I'll lecture a while, I'll stop, and you can ask questions. Probably same thing Wednesday. There's a good chance I might want to go ahead and sneak in a little bit of chapter 4 anyway, whether you like it or not, so to speak. That might be part of tomorrow, okay? So, but Thursday, I will try to reserve Thursday for questions and answers before the test on Friday. Now that we've had a couple of exams, you know my exam rules by now, so you know what's going on. You can turn in the homework early, anytime on Friday before the test is fine, but otherwise, what is it, 9:01 or 9:02 a.m. on Friday, I will send by Canvas announcements, the exam, but I also project it like this. And you can have your cheat sheet, a 1 8.5 by 11 sheet front and back. You don't have to turn in your cheat sheet. And then when class ends at 10 o'clock, then you have 5 more minutes to submit your exam. So you can take pictures, click, 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 click. Or if you have a scanner, like Cam Scanner or something like that, you can scan it. So that needs to be to me by 10:05. Then I'll give you until 10:30-ish to submit your homework, okay? So that's what's going to happen. And the assignment for 3.6 should be no change on that, 1 to 55 odd. All right. At the very end of class yesterday, somebody asked for 3.333. I didn't notice it until it was too late, so sorry about that, whoever asked for it. So I'll do that right now. 3.3 on page 154, number 33. Determine a polynomial p of x of least degree whose graph is shown in the figure. Okay, so you may notice there are 1, 2, 3, 4 zeros. Okay. So if there's 4 zeros, you have to have 4th degree. In fact, you can kind of tell what happens. That's going to be what? -3, -1, +1, and +4, right? Which means your polynomial is going to be a constant times. Let's see, that's negative. So you would have parentheses x plus 3, right? And that would be parentheses x plus 1. This one would be parentheses x minus 1. This one is parentheses x minus 4. I'm not going to write this down because we did it before, but the main thing is there's 1, 2, 3, 4 zeros. Since there's 4 zeros, you have to have a 4th degree polynomial. Okay? And that's a good lead-in to a couple of things that I want to emphasize again before I start doing the homework problems. Okay, so the answer to 3.333 is 4th degree because there are 1, 2, 3, 4 zeros, or 4 roots. Okay, and now we know, I mentioned this yesterday, but I'll mention it again. Page 182, section 3.6, the fundamental theorem of algebra. Okay, if you have an nth degree polynomial, you'll have precisely n zeros or n roots, provided you account for multiplicity. Okay, that means if you have a quadratic equation, there's exactly 2 roots. If you count multiplicity, in other words, you might say one of the zeros is 2, and another one is also 2. So that counts as 2. If it's 3rd degree, you have to have exactly 3. If it's 4th degree, you have to have 4. If it's 5th degree, you have to have exactly 5 if you're counting multiplicity. Okay, then the other biggie is the conjugate pairs of zeros. Okay, if we have real coefficients of a polynomial, okay, complex zeros are always in conjugate pairs. Okay, so whenever you have a plus bi as a solution, you automatically have a minus bi. So let's pretend one of the solutions comes out to be 2 minus 5i. You automatically have 2 plus 5i. And if you stop and think about, again, the way the quadratic formula works, right? The well-known quadratic formula. And I don't know why they write it like that. It's normally just all over 2a. Okay, or negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so you know the square root might come out to be negative, right? And we know how to tackle that now. So if you have a square root of a negative, you know you're going to have the imaginary stuff. And since in the formula there's a plus or minus, Okay, you'll have blah, blah, blah plus something I divided by whatever, and blah, blah, blah minus something I divided by whatever. Okay, which leads me to show that you always have conjugate pairs of polynomials. They always come in pairs. All right, so with that, I'll get started with a lot of the problems at the end now. Okay, so we're trying to find the zeros of these polynomials, and we're also going to try to build polynomials. Okay, so I have today and tomorrow to finish the rest of this. It should not be that bad. Okay, but a quick rehash. Okay, so the number of zeros. So let's say like x squared, there's going to be exactly 2. X to the 4th, there's exactly 4, right? Or x to the 5th, there's exactly 5, if you allow for this multiplicity stuff. Okay. All right, so here we go. Okay, 37, x to the 4th minus 4 equals 0. And just find all the solutions. We're also going to factor it all the way. Now we know how to factor it. Okay, so there has to be how many zeros? There has to be 4 zeros because it's 4th degree. Okay. That corresponds to that problem that we saw 3.333, right? It touched the x-axis 4 places. That means there's 4 zeros. So you have to have at least a 4th degree equation. Okay, let's factor this into the difference of 2 squares. X to the 4th can be thought of as x squared squared. And 4 is 2 squared. So I'm going to go x squared plus 2, x squared minus 2. So x squared plus 2 equals 0, or x squared minus 2 equals 0. This is the zero factor property. If something times something equals 0, either this one is 0 or this one is 0. Okay, move over the 2, move over the negative 2. I have x squared equals negative 2, or x squared equals positive 2. Take the square root, plus or minus. Okay, so that means you're going to have a square root of a negative 2. Okay, so that means there's an I involved. So we now know what to do. If you have a square root of a negative, that negative comes outside, stands up, and becomes an I. So I have x equals plus or minus I radical 2, or x equals plus or minus radical 2. Right? So these are the 4 solutions. Looking back over here, we're supposed to have 4 solutions. 1, 2, 3, 4, plus or minus I radical 2, and plus or minus radical 2. So no duplicates, so we don't have to worry about multiplicity this time. Okay, so again, back here I had x squared equals negative 2. You know you have imaginary stuff. X squared equals 2. So I do the square root property. So plus or minus square root of 2. Plus or minus square root of negative 2 means take out the negative, it becomes I radical 2. Okay, and now how do you write it factored? Well, remember what we did last time at the end of yesterday, right? So, or remember if you have a solution of 3, then you know you're going to go parentheses x minus 3. So you go x minus each of these solutions. Okay, so I go x minus I radical 2, x plus I radical 2, x minus radical 2, x plus radical 2. So this is the complete factorization of x to the 4th minus 4 now. Okay, you basically go x minus each of these. X minus that, x minus the negative, that's a double negative giving me a positive. X minus radical 2, x minus a minus radical 2, x plus radical 2. Okay. All right, next one I was going to show you is a 41. So this one. X cubed plus 8 equals 0. Okay. So right away, you know you're going to have how many solutions? It's going to be 3 because it's 3rd degree. So we want to try to find the 3. All right, so first I move the 8 over. X cubed equals negative 8. Take the cube root of both sides. The cube root of negative 8 is a real number. It's negative 2. Which tells me x plus 2 is a factor. Okay? But now I want to do the division. You can either do long division, which I don't feel like doing, or synthetic division. Synthetic division is a lot better. Okay, so I'll divide x cubed plus 8. Notice I have to put 1, 0, 0, 8. Why do I have the zeros? Because you have to think of this as x cubed plus 0x squared plus 0x plus 8, right? So 1, 0, 0, 8. This is 1s. This is x's. There are no x's, so count it as 0. This is x squared. There are no x squared, so count that as a 0, and then 1x cubed. And then the 0 was -2. Okay. All right, so 1 comes straight down. Multiply, -2, add. Multiply, -2 times -2, 4, add. Multiply, -2 times 4 is -8, add. Okay, remainder is 0, which is what we're hoping for. And now that's 1's, x's, and x squared. So this reads as x squared minus 2x plus 4. So now the original polynomial x cubed plus 8, the f of x, is x plus 2. Remember you changed the sign for this for a factor. If I plug in -2, I get 0. That tells me x plus 2 is a factor. And then this is x squared minus 2x plus 4. Okay. By the way, double check. What do you get when you plug in -2, right? If you put a -2 here and here and here. Well, putting a -2 here automatically makes this 0. So 0 times whatever that is also 0. Okay, so that's good. And now that I have a second degree equation, I can go straight to the quadratic formula. Okay, that's not factorable. So let's go with it. So I set x squared minus 2x plus 4 equal to 0. Use the quadratic formula. If you've forgotten the quadratic formula, you may put it on your cheat sheet. But again, if we were meeting face to face, I would make you guys memorize it. All right, so A is 1, B is -2, C is 4. All right, so quadratic formula, x is equal to -b, +2, plus or minus the square root of b squared, -2 squared is 4. By formula, minus 4ac, minus 4 times a, which is 1, times c, which is 4, all divided by 2a, 2 times 1. Okay. And I notice this is scratch paper here. 4 minus 16, it's a -12. So I'm going to have that I stuff. Okay. And they're going to be in conjugate pairs, as you can see. So 2 plus or minus the square root of -12. So how do we deal with the square root of a -12? Just make this negative come outside and stand up as an I. So 2 plus or minus I radical 12. And you can see the conjugate pairs, right? I've got 2 minus blah, blah, blah divided by 2 and 2 plus blah, blah, blah divided by 2. So they're always in conjugate pairs. Okay, and 12 is 4 times 3, right? So write it as I radical 4 times 3. 4 comes outside and changes to a 2. So 2 plus or minus 2i radical 3. Then what's all this red stuff? It means there's a 2 here, there's a 2 here, there's a 2 here. So you can divide 2 into all of them. So 2 divided by 2 is 1. This 2 divided by 2 is 1. So I have 1i radical 3. But if it's 1i radical 3, just write I radical 3. Okay, so I have 1 plus or minus I radical 3. So there we are. So we have our 3 zeros. So way back here, third degree, right? So we're going to have 3 zeros. Looks like there's only one of them that's real, -2. The others are complex, 1 plus or minus I radical 3. Or you can write it as 1 plus or minus radical 3 I if you're writing it in the form A plus BI. So how do you write a factor now? Well, to write a factor, you go x minus each of these. So x minus a -2, right? And then x minus parentheses 1 minus I radical 3. And then bracket x minus parentheses 1 plus I radical 3. And you can stop there. You don't have to distribute any farther. But that's the complete factorization of x cubed plus 8. So the nice one was this. These two are definitely not nice. And by the way, I won't take the time to do that, but it does check. Well, -2 is easy to check, right? -2 cubed is -8. -8 plus 8 is equal to 0. But believe it or not, if you were to take each of these guys, like let's take 1 plus radical 3i. Okay. Believe it or not, I won't bother to do it. But if you cube that, if you take that weird thing, multiply it by itself 3 times, and then add it to 8, you'll get 0. Okay, so that's the way that one's going to work. Okay, for 45, let me show you the wording. Given that the value of x is a solution of the equation, find all solutions. Okay, so 45, they give me this big long thing. It's fourth degree. All right, so fourth degree means how many zeros are there be? How many solutions would there be? There must be 4 if you allow for multiplicity. And they tell me one of the solutions is I. All right, so one of them is I. The other one automatically has to be negative I. You can pretend this is 0 plus I. The conjugate is 0 minus I. So that's this conjugate pairs business again. Okay. If you know that you have one complex solution, its conjugate is also a 0. So I is like 0 plus I. The conjugate is 0 minus I. All right. Okay, so automatically x equals negative I is also a root or 0 of the solution. Okay, so what I'm going to do right now is figure out what's x plus I, x minus I. Okay, so multiply out x plus I, x minus I. It's x squared minus I squared. And that's x squared minus a negative 1. Remember, anytime you see I squared, it's negative 1. So it's x squared plus 1. All right, I will now do polynomial long division of this. So if I divide this mess by x squared plus 1, there should be no remainder. So here we are. Here's the original polynomial. Here's x squared plus 1. Okay, a word of caution. You say, why don't I do synthetic division like over here? You cannot do synthetic division on second degree or higher polynomials. Okay, synthetic division only works when you have a first degree polynomial like x plus 2 or x minus 5. Then you can do it. Not when you have x squared or higher. So we're forced to do long division. It's a nice review anyway. Okay, of course, pretend you don't know the answer up here. So first thing here, first thing here. How do you go from x squared to x to the 4th? Multiply by x squared. Okay, x squared times this whole thing. X squared times x squared is x to the 4th. X squared, there's supposed to be an x term, let's call it 0. So x squared times 0x is 0x cubed, right? X squared times 1 is x squared. Okay, so there's supposed to be a 0x. You could afford to leave this one out. It's more critical not to leave anything out here. Whoops, what happened? Lost that somehow. Let me see if I can get it back.